The first thing to understand is that mathematics is an art. The difference between math and other arts, such as music and painting, is that our culture does not recognize it as such. Everyone understands that poets, painters, and musicians create works of art and are expressing themselves in word, image, and sound. In fact, our society is rather generous when it comes to creative expression. Architects, chefs, and even television directors are considered to be working artists. So why not mathematicians? Part of the problem is that nobody has the faintest idea of what mathematicians do. The common perception seems to be that mathematicians are somehow connected with science. Perhaps they help scientists with their formulas or feed big numbers into computers for some reason or the other. There's no question that if the world were to be divided into poetic dreamers and rational thinkers, most people would place mathematicians in the latter category. Nevertheless, the fact is that there is nothing as dreamy and poetic, nothing as radical, subversive, and psychedelic as mathematics. It is every bit as mind-blowing as cosmology or physics, and allows for more freedom of expression than poetry, art, or music. Mathematics is the purest of the arts, as well as the most misunderstood. So let me try to explain what mathematics is, and what mathematicians do. I can hardly do better than to begin with G.H. Hardy's excellent description. A mathematician, like a painter or poet, is a maker of patterns. If his patterns are more permanent than theirs, it is because they are made with ideas. So mathematicians sit around making patterns of ideas. What sort of patterns? What sort of ideas? Ideas about rhinoceros? No. Those are left to the biologists. Ideas about language and culture? No, not usually. These things are far too complicated for most mathematicians' tastes. If there is anything like a unifying aesthetic principle in mathematics, it is that simple is beautiful. Mathematicians enjoy thinking about the simplest possible things and in the simplest possible imagery. For example, if I'm in the mood to think about shapes, as I often am, I might imagine a triangle inside a rectangular box. I wonder how much of that box the triangle takes up. 2/3 maybe? The important thing is to understand that I'm not talking about the drawing of the triangular box, nor am I talking about some metal triangle forming part of a girder system in a bridge. There's no ulterior practical purpose here. I'm just playing. That's what mathematics is. Wondering, playing, amusing yourself with your imagination. For one thing, the question of how much of the box the triangle takes up doesn't even make any real sense in physical objects. Even the most carefully made physical triangle is still a hopelessly complicated collection of jiggling atoms. It changes size from one minute to the next. That is, unless we're talking about some sort of approximate measurements. Well, that's where the aesthetic comes in. That's just not, and consequently, it is an ugly question that depends on all sorts of real-world details. Let's leave that to the scientists. The mathematical question is about the imaginary triangle inside the imaginary box. The edges are perfect because we want them to be. That is the sort of object I prefer to think about. This is a major theme in mathematics. Things are what you want them to be. You have endless choices. There is no reality to get in the way. On the other hand, once you've made your choices, for example, I might have chose to make the triangle symmetrical or not, then your new creations do what they want to do, whether you like it or not. This is the amazing part about imaginary patterns. They talk back. The triangle takes up a certain amount of its box. I don't have any control over what amount that is. There is a number out there. Maybe it's 2/3, maybe it isn't. But I don't get to say what it is. I have to find out what it is. So we get to play and imagine what we want and make patterns and ask questions about them. But how do we answer these questions? It's not at all like science. There's no experiment I can do with test tubes and equipment and whatnot that will tell me the truth about the figment of my imagination. The only way to get to the truth about our imaginations is to use our imaginations, and that is the hard work. In the case of the triangle and its box, I do see something simple and pretty. If I chop the rectangle into two pieces like this, I can see that each piece is cut diagonally in half by the sides of the triangle. So there is as much space inside the triangle as outside. That means that the triangle must take up exactly half of the box. This is what a piece of mathematics looks and feels like. That little narrative is an example of the mathematician's art, asking simple and elegant questions about our imaginary creations and crafting satisfying and beautiful explanations. There is really nothing else quite like the realm of pure idea. It's fascinating, it's fun, and it's free. Now, where did this idea of mine come from? How did I know to draw that line? How does a painter know where to put his brush? Inspiration, experience, trial and error, dumb luck. That's the art of it. Creating these beautiful poems of thought, these sonnets of pure reason, there's something wonderfully transformational about this art form. The relationship between the triangle and the rectangle was a mystery, and then that one little line made it obvious. I couldn't see, and then all of a sudden I could. Somehow I was able to create a profound, simple beauty out of nothing, and change myself in the process. Isn't that what art is all about?